Like you really have to love this first question here, right? Give us more of these, right? So show that the time taken for the battery to discharge is about 3,000 seconds, right? That's what 3 times 10 to the third is, right? Is it possible we can get that from this and this, right? Remember, the distance is 20,000 meters. The velocity is 7 meters per second. What time does it take? Okay, now I'm going to give you the formula. You ought to be able to figure that out, right? It's moving at a constant speed. Deduce that the average power output of the battery is about 240 watts, right? So the question is how much energy it's got, right? Because power is work divided by time, right? Okay. Now we know how many seconds it takes, right? So you'll figure this out. By the way, it's not 3,000. I get something like around 28 or 2,900 seconds, right? So that'll be your time. I'll just stick that in there for time, right? So then the question is how much energy is in the battery, right? And we're going to say it's 16 volts, and it can hold 43 kilocoulombs of charge, right? Right. So assuming the battery voltage doesn't drop, right? The total energy in the battery is just Q times V, right? And this comes from what V is, or E, potential energy is change in voltage times Q or something like that, right? So if we multiply the charge by the voltage, we'll get the work. So plug that in, right? The charge is 43 kilocoulombs and the voltage is 16 volts. So multiply those together, right? And you'll get something. I got something that was a little bit more than 240. Okay. And then it says friction and air resistance on the bicycle and the girl act on the girl when they move. Assume that all the energy is transferred from the battery to the electric motor. Determine the total average resistive force that acts on the bicycle and the girl, right? So we're just going to say work is force times distance, right? The work also is QV, right? So they're saying that all of this electrical energy turns into this, right? So you know Q is what, 43 kilocoulombs. V is the voltage, not the velocity, right? Is 16 volts. It's 20,000 meters is your S, right? It goes 20 kilometers, right? There's your S. Solve for F, right? Because these guys are equal to each other. The force times the distance is equal to the Q times the V. All right. This is the most adorable picture. Like, look at that. She's going up the hill. She's got long hair. All right. Calculate the component of weight, right? So this is going to be the force parallel, right? So that's going to be, right? It's like this sloping thing, right? We've got the force of gravity straight down. There's a component parallel to the plane. Component perpendicular. This is the hypotenuse. That's mg. Do you remember this? Remember the force parallel, right? Okay, so these guys are congruent. Those angles are congruent, right? And so this parallel component of Earth's gravity is equal to mg. So you've got her mass. You've got g, right? It's going to be mg sine theta, right? Now, strangely, and this is a very strange thing, when you, in the previous question, right, where we just calculated a force, you get almost the same answer, which I thought is just sort of strange. Like I'd write the question differently, but they did that, right? So this ends up being somewhere between 30 and 40, just like the question that you answered before, right? And then letter 2 says, the battery continues to give an output of 240 watts. Assume that the resistive forces are the same as in AIII, right? Calculate the maximum speed of the bicycle and the girl up the slope, right? Okay, so what are our forces? Well, our forces are whatever you got for this, right? Right, and this thing's, between 30 and 40, right? And the force is also what you figure out here, right? The component of the weight, right? So you're going to add those two forces together, right? And it's 240 watts. Remember, the power is force times velocity. The power is going to be 240 watts, right? The force is what we're going to figure out. That force is the answer to this and the answer to that last question, right? It's going to be F plus F, right? So So assume that the resistive force, so this would be the resistive force, this would be the force of gravity, right? Which is ridiculous, right? Because if you slow down, that resistive force would get less. But that's okay, let's go with it. Okay, they're saying it doesn't change, so let's go with it. So again, for the force, you're going to add up the force you got here and the force you got in that last question. And that's going to be your force. So basically its power is the sum of those two forces times the velocity. Solve for the velocity. The velocity is on the order of half the velocity that it had before, which is 7, right? It's around 3.5. All right. On another journey up the slope, the girl carries an additional mass. Explain whether carrying this mass will change the maximum distance that the bicycle can travel along the slope. I'll leave that one up to you. What do you think? If she's carrying extra mass, right, is that going to change how far she can travel up the slope? It's going to affect something, right? So talk about it. It's going to affect one of these forces. Maybe this force, right? If it's not 66 kilograms, if it's more kilograms, right, this force will change. So talk about how that would change, right? And talk about how that would change the distance it can travel. Okay, remember that what work is force times distance, right? Work is the total energy you have. Force would be the combined forces like that, right? And the distances. There it is. Okay. All right, yet this problem keeps going, right? It's like, oh my gosh, right? So, how the heck do we do this, right? So determine the internal resistance of the battery, right? So notice it's saying that it's 12 volts, right? But remember the EMF of the cell is 16 volts. So the internal resistance, the formula is that the terminal voltage, which is what we have here, right? So 12 is equal to the EMF of the battery, which is 16, right? Minus I times R. And this is our R internal. Because remember, one model for a cell is that it's like a resistor plus a cell, right? We pretend that this is the cell, right? And so it's the EMF minus IR, because the voltage will drop across that, right? So you're going to put the 12 in for this. The EMF is 16. The current is going to be 6.5. Solve for R, right? And you're going to get something between 0 and 1. It's smaller than 1, okay? It's about halfway, okay? Okay, the battery is made of 10 identical cells, as shown, right? So these guys, by the way, when you put cells in parallel, you increase the current you can draw. When you place them in series, you add the voltages, right? So if we have two batteries like this is pretty straightforward. If this is a 6-volt battery and that's a cell, right? Then the battery from here to here is going to read 12 volts. Yeah? Because it's literally, you can just go up 6 volts and then up 6 more volts is 12 volts, okay? So there are 10 identical cells. Find the EMF of one cell. Well, we know the EMF here is 16 volts, right? Okay. And we have, basically, when you hook them in parallel, they have the same voltage. They can just create more current, right? So this is V plus whatever the voltage of one cell is, right? Plus V. There's 1, 2, 3, 4, 5 V's added together equals 16, right? So V plus V plus V plus V plus V is 16. Or 5 times V. Wait, did I do enough V's? I did. I did the right number, right? Or 5 times V is 16, right? Okay. And then calculate the internal resistance of one cell. This is tough. Okay, well, remember, each cell is like this. It's got its own little resistor in there, right? Okay. And there's going to be 5 of those in series. So that's going to be times 5, right? So you've got some answer here. It's the internal resistance of the entire battery, right? You've got that answer. That answer is whatever you got here is going to equal the resistance of one of these cells times 5. But because we've got 2 in parallel, remember when you do 2 in parallel, it's going to be divided by 2, right? So it equals that times whatever that internal resistance is, right? So whatever answer you get there it's going to be 5 halves of this resistance, right? Is that right? Yeah, yeah. So you can solve for this resistance. God, does this thing keep going? I feel like I've been doing this one forever. No, that's it. All right, good enough. Good riddance.